With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? A thin annular disk of outer radius capital R and R by 2 is the inner radius and it is having a charge of Q which is uniformly distributed over its surface. Now this disk is rotating with an axis at a constant angular velocity omega. We need to find the correct option for the magnetic field intensity and for the magnetic moment. Okay, so let us draw our disk. Let's say this is our disk. Okay, and let's say this is our inner this is basically annular disk. So this is having a radius r by 2 and this is having a radius of capital R. Okay, now this disk is rotating. Now when this disk is rotating, it is having a charge capital Q. Okay, so we can just find what is the value of the charge density sigma. So sigma would be equals to Q charge divided by the area. So what would be the area? So area would be Q by area would be pi r square minus r square by 4. So it would be 4q divided by 3 pi r square. This would be the value of the sigma, this charge density. Why we are finding the charge density? Because the charge which is placed on this charge is rotating. Now if the charge is rotating, then the basically charge is moving, then moving charge would constitute a current. So current would be constituted, therefore there will be magnetic field and magnetic moment. Now what would be the value of the current? Di is small element, this is small current. It would be equals to, for example, if we assume that there is a small disk. Okay, if we just assume we draw just a small disk, we are just drawing a small, very small circle. Let's say this is our small circle which is having a small radius. Okay, so it is just having a small radius. Let's draw it like this, small thickness. Okay, so it is at a distance of small r and the thickness is let's say dr. Now the charge which is inside this loop, so basically it is rotating with angular velocity omega. So due to rotation, it would be constituting a current. So what would be the charge in this disk, small disk? So it would be Q divided by, and in one revolution it would be taking a time of capital T, time period. So what would be the value of this charge Q, dq? We just write. So dq would be equals to sigma multiplied by the area. So what is the area of the strip? 2 pi r into dr. This is the value of the area. Now what is the value of the time period? It is 2 pi over omega. Then our di would turn out to be, the current would turn out to be sigma omega r into dr. So this is the value of the this current. Now we need to find what is the value of the magnetic field intensity. Okay, now magnetic field intensity, if you find magnetic field intensity at center. Okay, we need to find this value at center. Now first of all, what we can do, we can find the magnetic field intensity due to this strip at the center and then we can integrate it. So magnetic field intensity at the center is given as dB, small magnetic field intensity, would be mu naught into the current which is constituted by this. It is equals to this di divided by 2 and the distance from the center which is equals to smaller. Okay, so we have just made for the, we have just calculated the magnetic field due to this strip. Now there would be several strips, several such strip on this. So but each would be rotating similarly. That means each would be rotating. We have drawn the direction to be the clockwise. So they would be having the magnetic field in the downward, perpendicular to the plane of the paper, inside the plane of the paper. Okay, each and every magnetic field. So what we can do, we can just integrate this. So our total magnetic field would be just integration of this magnetic field. Okay, now we can put the value of di. Di value sigma omega. So its value is sigma omega r dr divided by 2r. Now r and r would be cancelled. So what is just left? So the left portion would be mu naught sigma omega divided by 2, and then it would be just, so what is the limit? It would be from r by 2 to r. Okay, the inside radius is r by 2, outside radius is capital R. So we have put the value. So integration, so this and this r would be gone, then integration would be of dr. So integration of dr is r. So we can put the limit in r as limit as r by 2. This upper limit as r and lower limit as r by 2. So if we solve this, then our magnetic field intensity would turn out to be mu naught sigma omega divided by 2 into r by 2, or we can say that it would be equals to mu naught omega r divided by 4 into what is the value of this sigma. Sigma value we have calculated as to be 4q divided by 3 pi. So 4q divided by 3 pi r square. So it would turn out to be mu naught, then omega, then divided by 3 pi r. This is the value of the magnetic field. So if we check our option, so which option would be the correct? A option is the correct, B is incorrect. Also, we need to find the value of the magnetic moment. So how to find the value of the magnetic moment? Magnetic moment. Magnetic moment. So similarly, we will be doing, so magnetic moment due to small current is given as to be N into A into di. Now there is just a single loop, so it would be equals to A into di. Now, if we need to find the value of the total moment, we can just integrate this magnetic moment. And if we perform here integration also, what is this area? This is the area of the cross section, which is equals to pi r square. Okay. Now what is the value of the di? Di value, we know that its value is given as to be sigma omega r into dr. Okay. So what would be the limit from r by 2 to r? This would be the limit. So what are the constant term which we can take to be outside? So it would be sigma omega pi. So these are the constant term, and then it would be integration of r cube into dr. So integration of r cube would be r by 4. So r to the power 4 by 4, and we can put the limit r by 2 to r. Okay. Now what would be this term equals to? It would be equivalent to sigma omega pi, then it would be r to the power 4 minus r to the power 4 by 2 to the power 4 is 16. And there would be 4 here. So finally, it would turn out to be sigma omega pi by 4 into 15 r to the power 4 by 16. Now we can put the value of the sigma. So if you put the value of sigma as 4q divided by 3 pi r square into omega pi by 16 into omega pi by 4. It is omega pi by 4. Omega pi by 4 into 15 r to the power 4 by 16. So this, our final answer would be 5 pi omega q r square divided by 16. So this would be the value. So if we check which option would be the correct option, so the correct option would be our C option. D is the incorrect. So hope you have understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.